week. And speaking of next week, I am going to stick with the Tuesday, Wednesday quiz days. So A through K, if you're in class on Tuesday, you'll take it. Anybody that hasn't taken it on Tuesday, you'll take it on Wednesday. And then if you're not taking it, you'll watch the video like traditionally we always have. All right? So Tuesday, basically, if you guys are in class, you're taking it. All right, Wednesday will be everybody else. And I will be reviewing on Monday in class. All right? You guys, I have taught everything that'll be on the quiz. Hill SAS, Pythag, 30, 60, 90. So what are we doing today? We're doing a little tougher 30, 60, 90. All right, because this year, unfortunately, as you guys know, we haven't been able to do as much enrichment as I currently do as I usually do during an honors level year, but we're doing it today. All right, so we're going to take the 30, 60, 90, and 45, 45, 90 and jack it up a bit. All right, jack it up. All right, so let's take a look at number one. There's only 4 examples today. All right, and they're going to be pretty tough. So number one, you guys identified pretty clearly it's a 30, 60, 90. So I'll start this discussion off with this question. What side did I give you? Remember, in a 30, 60, 90, you have a shorter leg, a longer leg, and a hypotenuse. So what did I start this problem off by giving you? What is the 12 acting as? What's the 12? Let's start this off right. Here we go. Omni, what's that 12 there? That's the longer leg, and I have X on what, Omni? What size X? Okay, so I gave you the longer leg, and I'm looking for the hypotenuse. Problem, your 2 rules don't tell you how to go from hypotenuse to longer leg, correct? It always involves the shorter leg. Oh boy. So do I come up with the 3rd rule? Absolutely not. There's enough to remember already. So how can I use these 2 rules to get from the longer leg to the hypotenuse? Find the what first? What can I find given the longer leg? The shorter leg. So I'm going to find the shorter leg first. That'll get me to the hypotenuse. Okay, everyone at home, see my plan. Since I have no rule that connects the longer leg to the hypotenuse, I'm going to find the shorter leg first. So, hey, I'll throw a Y on the shorter leg. All right, here we go. So it says longer leg, 12 equals shorter leg, Y, times radical 3. I just used this rule right here, just so everybody knows. That's the rule I just used. Longer leg equals shorter times radical 3. All right, here we go. Here's why it's tough today, is this algebra I'm going to have you do. How do I get 19? Here we go. Sean, how do I get that Y by itself? What do I need to do with radical 3? Divide radical 3 on both sides, all right? And everyone just stop right now after I do that, because do not go to your calculator. I don't want that decimal. All right, because last year you guys ended pretty abruptly in March, I'm sure first period didn't have any idea, so I'm assuming that you guys are in the same boat about dividing radicals. All right, so this is where I need to stop and take my time right now, and you guys got to focus in and ask any question that you have. You can never leave a radical in the denominator of an answer, okay? You cannot leave a radical in the denominator. So this answer, 12 over radical 3, is not going to fly. So how do I get it out of the denominator then, Mr. Carlino, right? How do I get it out? Here we go. Step by step, very easy here. Have you guys did this last year or no? Some of you have, some of you, okay. I don't know how 2 out of 60 have, but okay. So here's how we're going to do it. How do I get a radical out of the denominator? Because that's a no-go. You cannot leave an answer like that. What we're going to do is we are going to multiply the top and the bottom by the radical. So watch. I'm going to take 12 over radical 3 and multiply it by, and I'm sorry I'm writing so small. I don't have that much room. Radical 3 over radical 3. To get a radical out of the denominator, I multiply the numerator and the denominator by the radical. Here's why that's okay. If you're wondering, here's why I want to explain why this is okay. What's radical 3 over radical 3? 1. You multiply anything by 1, are you changing it? No, so that's why this is okay. I'm not changing the value of anything. All right, so let's keep going now. So I have y equals, ready? Let's talk about what's left in the numerator. 12 times radical 3, I just write 12 radical 3. Here comes the magic. You guys have done this with me a lot this year, well, this unit. Radical 3 times radical 3. You multiply a radical by itself, number underneath. Look what happened. What disappeared? Radical in the denominator. No more. So to remove a radical, you multiply top and bottom by it. But you're not done. Oh, you're not done. We can do still a little something here. We can still do a little something here. What's it look like I can still do to that fraction? Talk to me. Yeah, 13. Here we go. Sophia, what's it look like I could still do here?
You can simplify radical.
3?
No.
No, you're good. Yep. That'd be a tough one.
I'm not sure.
You got a 12, and you got a 3 on the bottom. Go ahead. 12 divided by 3, so this is going to end up being 4 radical 3 for your final short side. Not my answer, right? That's just short side. That's short leg. All right, now let's go back. Any questions at home right there? That whole process, divide by radical 3, get it out of the denominator and simplify. All right, now let's actually answer the question, which is how do I find the hypotenuse now? Tell me the rule. I know you wrote it down, but I want to hear it. I want to hear it. 15, here we go. Will, good morning. Will, how do I find the hypotenuse in a 30, 60, 90?
You multiply the shorter leg by 2.
Shorter leg, which we just found, was 4 radical 3. So here we go. Hypotenuse equals shorter leg times 2. Are we okay with that? No, I know not leaving. I'm saying handling it on me. I know, I'm not good with you leaving it like that either, but are we okay on handling that? I just do 4 times 2, 8 radical 3. So there is your hypotenuse. Whew. Getting tired already. Everyone all right there? That's not the last time I'm going to divide by a radical today either, so don't worry. That's not the last time. Everyone okay there? I had to find the shorter leg first to get to the hypotenuse. You guys at home want to ask any questions? All right, let's keep stepping it up. Number 2. Oh, love these. You got a 45-45 and a 30-60 in the same diagram. So AB 2. We need to get to BC X. Got it. Well, we got a problem, guys, don't we? I got the 2's in a 45-45, and the darn side I need to find is in a 30-60-90. So no shot. We're going to go right from AB to BC in one step. No shot. No shot. So why don't we find one of the legs? Guys, what do you know about the legs in a 45-45? They're equal, so it doesn't really matter which one I find here. I find one, I find both. So I'm going to take this 45-45 right now. And we're going to find one of the legs. All right, tell me the fact. Hypotenuse and leg. Tell me the fact. 2-4. Here we go. Emily, good morning. What's the fact that relates a leg to the hypotenuse in a 45-45, Emily?
Multiply the leg by radical 2.
Okay, so here we go. Hypotenuse 2 equals leg, and I'll just call the leg y, and it doesn't matter. They're both y. Y times, what again, Emily? I'm sorry. Times?
Radical 2.
Radical 2. Good work. Everyone see what we're doing? All right, how do I get rid of the radical 2? Uh-oh. How do I solve for that leg? Here we go, 1-5. Will, back to you. How do I solve for y, Will?
Divide both sides by radical 2.
Good deal, good deal. Divide both sides by radical 2, and here we are again. Okay, here we are a second time now. I can't have a radical in the denominator, so I'll still go slow, still going slow. So to get the radical out of the denominator, give myself a little more room. I multiply top and bottom by that radical. Basically, I'm just still multiplying by 1. All right, so one of the legs, y equals, help me out. Tell me what I get on top and what I get on the denominator. 1/8, 1/8. Owen, going to you. What's on top now? When I multiply the numerators.
2 radical 2.
2 radical 2, and what's on the bottom?
2.
2. No more radical. Ding. What's up?
Oh, I haven't been showing it as like a 2 equals y radical 2. I just like kind of went straight to 2 over radical 2.
Fine. Fine. I'm not going to fight it. Yep, you're fine. I can still keep going, though. Hey, we're not done yet. You can still simplify that bad boy. There's still something I can do there. Help me out. What can I do here? Ooh, 9 spot. Here we go. Audrey, good morning.
Good morning to you. You could divide the 2 by the 2 in the denominator and then just leave it radical 2.
Done. Radical 2. So both legs up here are radical 2. Get rid of that. Okay, so here you go. Radical 2, radical 2. Oh, now that I know BD, now I know a side in my 30, 60, 90. So here's the second half of this problem now. What side do I know? Shorter, longer, hypotenuse. What do you got for me? Shorter, longer, hypotenuse. 2, 5. Everyone at home. Good morning, Sabrina. The radical 2, Sabrina, we just found, is that the shorter, longer leg or hypotenuse in my 30, 60, 90? Shorter. Great job. Somebody else, give me the rule that relates the shorter to the hypotenuse. 7, here we go. St. John, shorter to the hypotenuse. What's the rule?
Shorter times 2 equals the hypotenuse.
Okay, hypotenuse, x equals shorter times 2. That's what the rule says. And then you guys can take it from here. BC is going to be 2 radical 2. Any questions, comments, concerns for you guys? Anybody at home want to ring in? We're halfway done. Look at that already. Having fun. Halfway done. Whew. All right. 3. Find the perimeter of this rectangle. All right. I'm going to make, I'm going to make this difficult on you. I only see 30 degrees. Why are we just assuming the other two are 60 and 90? You better prove to me mathematically why, Lucas. Where are you?
It's a rectangle.
It's a rectangle. What type of angles are in a rectangle?
490 degrees.
Oh, correct. So angle C is 90. That must mean that's 60. That's how we prove that's a 30-60 in here. We don't assume that garbage. All right, rectangle, find the perimeter. So you got to help me find the sides. All right, question. Let's roll. Omni, what is the 12 acting as in that 30, 60, 90?
The hypotenuse.
Hypotenuse. Okay, so I'm going to call the shorter leg X and the longer leg Y. So that's the hypotenuse, and I know there's some rule out there that says something about hypotenuse and shorter leg. I know it, but Quincy, here you go. Hypotenuse and shorter leg. What's the relationship? 30, 60, 90.
The hypotenuse is the shorter leg times 2.
There you go. 2 times my shorter leg X. Oh, that's pretty easy. Once I know the darn rule. So the shorter leg's got to be 6. Somebody tell me that other rule that goes from shorter to longer for me. Shorter to longer. 19 here. Sean, back to you. What's that rule that relates shorter to longer?
It's shorter leg times radical 3.
Okay, so longer equals shorter. 6 times radical 3. Don't need to do anything there. All right, here we go. What did I have here? 6 radical 3. Guys, what do you know about a rectangle that I can find the other two sides pretty quickly? Yes, Audrey?
Opposite sides are congruent.
So 6 radical 3 up here and 6 over here. All right, perimeter time now. I got 6 and 6, and then I have 6 radical 3, 6 radical 3. Oh boy, more radical talk. Okay, what do you think here? I can't combine all 4. Cannot combine all 4. They don't all have radical 3s with them. Can't combine all 4. Give me some thoughts here. What do you think you can combine for your perimeter? Oh, Sean, going back to you. What do you think you can combine up here, Sean?
The 2 radicals and the 2 non-radicals.
Okay, so 6 and 6 give me 12. So you're saying I can add 6 radical 3 and 6 radical 3?
Yes.
Yes, they both have a radical 3 in front. It's okay. Done. Cannot stop. Stop. You can't combine them. Okay, they both would have to have a radical 3 for me to keep going. You cats at home all right? I don't know about cat. I probably got some hungry dogs there, though. All right, you guys good? You want more? You got it. One more to feed you, and then you can get to your assignment. Ooh, equilateral. That tells me some facts. Equilateral has a side of 20, meaning they're all 20, right? I'll just throw 20 on that side. You guys don't have nearest 10th on your directions. You have simplest radical form, correct?
No, we have nearest 10.
You do? Garbage. You're going simplest radical form. Garbage. We don't do. What's the height of the equilateral triangle? Before we begin, bonus here. Time for anybody to show off. A vocabulary term we have already discussed this year that is also called the height of the triangle. The altitude, yes. So if you want to put altitude under height, that's the same thing. I'm looking for the height, aka the altitude. And from our discussion on altitude, you remember it starts at a vertice and does what? Goes down, yep.
Forms a 90-degree angle.
Forms a 90-degree angle, yeah. There we go. Altitude. But hey, they told us it was equilateral. What else what other degree measure should I put up here? Sophia?
Because it bisects the angle at the top, I think, it would give me a look like I'm saying something wrong.
Nope, go ahead, I'm listening.
Alright. Because it's 180 divided by 3, it would be, because we know you do 180 degrees in the whole triangle. I believe it's 60.
Okay, that's-
divided by 3.
That's no, I just wanted, there you go, you're good at, we're 60 right there. That's 60 because it's equilateral, and then yes, as we know now, guys, hey, that one's got to be 30, and you're finding the height. That's what you're finding. Okay, so everyone all right with our setup?
Oh, sure.
Everyone okay with the degree measures? All right, quick couple questions for you then. Kids, couple questions. 2, 6. Emma going all the way down there. Emma, what's the 20 in my 30, 60, 90? What side's that?
Oh, the hypotenuse.
And the side I'm looking for, the altitude, that's the what leg?
The longer leg.
Okay, so I have the hypotenuse. Thanks, Emma. I have the hypotenuse, and I'm looking for the longer leg. I don't believe either of the rules has both of those in the same one. So I'm going to have to find the what first? I'm not going to be able to find the longer one right away. But I do have enough information and rules to find
The shorter leg.
shorter leg. All right, somebody give me the rule. Hypotenuse is shorter. What's it say? Hypotenuse and shorter. Oh, there we go. Atticus, hypotenuse the shorter. What do you got?
The length of the hypotenuse.
How's it relate to the shorter?
It's half of the shorter.
Okay, so it's 2 times the shorter. I just want to stay consistent with my rules. So I'll call the shorter y. There we go. So that must mean the shorter leg is 10. Got it? And finally, to end this, how do I find the longer leg now? Boom, 2, 5. Sabrina, last one here. How do I find the longer leg, Sabrina?
Shorter leg times radical 3.
There you go. So x would be shorter 10 times radical 3. There you go. There's your altitude, 10 radical 3. Okay, before I let you go loose onto your homework, because that's what you're working on right now. It is due Monday. There's no more breaks in between here like we practice on Monday. We're done with that. All right, that's done. This week's over with. Just a little heads up. If a 45 or a 30-degree angle is not written in there, do not assume that it's a 30-60 or a 45-45. No assuming. You need to have the actual degree measure in there. If you're given, if you're given, let's say you just have a right triangle. And I don't know, that's 5 and that's 3. But you don't have any degree measures. Can you still find the other side? Oh, don't do this to me. Don't do this to me. Can you still find the other side even though it might not be a 45-45 or 30-60?
Yeah.
What do you have? Pythag. Thanks, Caroline. Thank you. Okay, so think about if you don't have any degree measures in a triangle in your homework, think about using Pythag. Go ahead. Rest of the time is yours. Stay on. Stay logged on. I'm going to be here for questions. Gave you half the class. 21 minutes.
How much work do you want to show for multiple choice?
Show all work. As much work as possible. Okay? More. Let me put it this way. I mean, more work than just circling the multiple choice. Whether that's labeling the diagram, that's fine with me. All right, but more work than just circling the answer. Because I did that on my answer key, so. Hopefully you guys at home heard that too. Multiple choice, show work. Okay, I won't accept it if you just circle an answer because I just did that on Classroom. So check your answers on Classroom as well.
So then when you're multiplying radicals, you can multiply the numbers underneath.
Correct. You are correct. Adding and subtracting, that rule does not apply. All right, I'm not.